is our agenda today. Okay, so I published the midterm module, guys, but I'm going to talk about in detail next week Tuesday. Okay, so but you have until March 15th, which means more than 3 weeks to do. One thing to note is that um, to access midterm projects, you must finish these two first. Okay, so this one is just weaving, it's a discussion, and this one is a small assignment that would take less than 30 minutes. Okay, and it's coming from the CCSF library, right? And once you finish these two things, then only you will get access to this one. So make a note of that. Okay, you will not be able to access directly this one without finishing either of these. Okay, all right, so let me go to the problem today. All right, so we're gonna draw this one. Let me I'm gonna quickly copy this code and then change that. Okay. All right, so I'm gonna remove this. So I have this thing.
This is module 4, right?
This is module 5. Okay. So this one, equilateral hexagon, we actually did this one, guys, last week, right? So all right, okay. So all right, so here's the problem statement. Okay, so what are the inputs? Let's start with that.
The length and the width.
There's no width over here.
Length.
Length, okay, side length, right? And
Even point on the bang. No.
yep, yeah, you're right. So given point, that's an input. Length, and then there's fill color as well. So those are actually inputs, right? So what part of speech recognizing the input? Given, right? The word given recognizes the input, right? So there may be many synonyms like that, like provided, given, and sometimes input may be hidden as well, like it's vague. The problem statement, it's kind of vague, but it's still, we should make an effort to isolate them, because knowing what you are given, right, it's easy to understand what the expectation, which is the output, right? So it helps you, right? So try to isolate them using that vocab word which is given here, right? So it identifies the input. All right, so I'm going to say length, and then the I would simply write x comma y, which is the starting point, right? So and then the color as well. Okay, all right, what is the output?
Equilateral.
Yeah, so equilateral hexagon, right? So right here. So basically these two things kind of recognizes the output to draw. Okay, so an equilateral hexagon. Okay, so that should be our output. All right, okay, so we can talk about the match right here. So do we have any matches for this one?
The equilateral triangle.
Yeah, that one and the rectangle one, right? Both of them are really good matches, right? So I'm going to say equi triangle and then rectangle. All right. So the idea is basically once you recall them, you may be able to do realize, okay, maybe it's a there are a lot of similar things to do in this problem too, right? And sometimes we may even copy that code to ourselves as well. Okay. All right. So I'm gonna go over here now, and so I'm gonna drop this one since previous class. All right. So we're gonna start right here. Okay. So this is where the turtle is sitting. So x comma y. Sorry, 0 0. Okay. So in general, the turtle sitting at 0 0, looking at east. Okay. So like here, what do we have to do first?
Is it saying that we need to determine the point where it starts?
Yes. So
So we need to move
to that point.
forward.
Yes. So then, what's the first step of moving there?
Forward. I thought I saw on
Mm-hmm.
that there was some new command
Mm-hmm.
move.
It's a go to function, right? Yeah.
Go to, yes.
Yeah. But before going, there's one thing we have to do. What is that?
Determine the angle. I know it's not pen.
No.
Pen up. Pen is a pen up.
Yeah, you have to lift. Otherwise, we will draw that line as well, right? For example, let's say we are going to start drawing from here. This is our x comma y, right? We have to move to this point, and then we're gonna draw our hexagon. But if we don't tail down up, we'll draw that line as well. So we'll have to tail up first, right? Tail up, and then we're gonna kind of move to this point. Okay. All right. That's why the broken line. Okay. So now the turtle is looking at east right here. What do we have to do now?
Pen down.
Yes, pen down again, right? Because the pen is now up, right? So we are now ready to draw. That means pen down. Then what? Now forward, right? Forward this way, right? This by length, right? Right? By length. And then what we have to do? By what?
With the 60?
Yeah, 60, right? How come 60?
That's what is it? 360 divided by
Yeah, so basically this is the equation, right? 360 divided by 6. Where are the 6? It's a hexagon, right? So and it's an equilateral hexagon, so all of these angles are same, and 360 by 60 gives you that value, right? So this is 60. Okay. So we are now basically now turtle is looking at somewhere northeast, and then we now move forward, right? By again length, right? All right. And then again we are in the similar situation. We have to turn again by 60, right? So turn left, left, and then we basically move again like this way, right? And then this we're gonna basically repeat this process, right? Again we're gonna turn, right, this way, and move again, and then move like this way and this way. We're gonna finish our hexagon, right? So this all of these angle are 60. Okay. All right. And these are this is L, L, and L. And you can see that this turning and moving forward process we're going to repeat 1 2 3 4 5 times more. Okay. So that's what we have to do. So try to draw this diagram always if this is a turtle based problem, because that gonna tells you a lot of things that you have to do from the turtle. Okay. All right. Okay, so we're gonna go over here now and write our algorithm. Okay, so that's our understand. um, Step one. What's the step one? What should be the step one?
in our plan, I
Mhm.
would say move to the given.
Before that,
Before that,
I mean, this has a clue.
Determine the input.
Yeah, input. We collect input first. All right. See that? I have given that code line first. That's the line one, right? The input. So that means you input, right? So, and then basically in function definition, input come in as parameters, and that's actually line one. This is step one. So it's good to have step one in our English as the same. Okay. So length, and x comma y. Okay. And then I actually even though I have given a color over here, I'm not gonna use color right now, but I'll add later, guys. Okay. All right. Two. What should be the step two? Actually, you said earlier.
I don't want to say that number again. I forgot. I said it earlier.
Yeah. Oh, sorry. Right here. We did it right here. We did right here. What is it? This one, right? Tail up. Yeah. So, tail up. Okay. All right. Next step.
Now we got to go to the.
Yes. Go to, right? So, go to is the function. You can use the same name as here as well. Go to x comma y. Okay. That's the starter location. Okay. So, 4. So, now what do we do? Yeah, tail down, right? Tail down. Yeah, pen down also fine. Okay. All right. So now what do we do?
Now we start drawing.
Yeah, forward, right? Forward by length. 6.
Left by
Left by
60.
60. All right. And you can see that we'll repeat this two step, right? So this one again, forward by length, right? So I'm going to copy paste this, guys, 5 more times, and I'm going to change the line numbers. Okay. All right. So
Wait,
and
so
this is
you
8.
copy pasting. So we just did 7 lines. So we copy pasting the 7 lines 5 times.
Yes, yeah. So I'm gonna change these numbers now. 6, 7, this 8, and 9, 10. Let me see. Yep, it's 11. Because that's what we did in the diagram too, right? So we repeated that, right? So 14 and 15. All right.
Quick
Yeah.
question.
Yep.
I think I finished this last class, but the whole moving to a new point first.
Mm-hmm.
That was here last class too. I just missed that part.
Oh, okay. Yeah.
Okay. So
Yeah, you'll see that. Yeah, today.
okay,
Yeah.
because I
Yeah.
submitted it without that.
That's fine. Yeah, I'm really glad you did submit. Yeah, you can change if you want. Yeah. All right. Okay. So try to get this one always. Okay. So because it tells you what to do, right? And then since we learn the turtle code, and then we actually know what function to use, then it's easy to kind of translate from here to our code. Okay. So I would say I recommend not to find shortcuts here, right? Because this is your algorithm, and make sure it actually solves your problem. Okay. So basically in computer science, we should say our algorithm should solve the problem. Okay. So all right. Okay. So now we can translate this one. Okay. So this is the first line translation. Okay. So we are collecting input, right? So those are that. Okay. And I'm going to pass a turtle, and later on I'll explain why that. Okay. So, and if you guys take a look on the code that I posted last week, in the review section, sorry, in the evaluate section, I added this one instead of creating the turtle inside my function. Take a look. Okay. All right. And you can see that I have the doc string. Basically, it says what it does. Always bring the verb, in this case draws, and then what are we drawing? An equilateral hexagon, and then of this length, sorry, and then at x comma y. Okay, all right. And then basically make sure to pick a correct name like this one, bring the verb to the front, and then add more things to make it more specific, and that's going to be your name of the function. So what did we call these two lines?
That's for defining the function.
Yeah, there's a name for these two lines. Yeah, public interface of the function. Okay, all right, all right. So now, so this line 1 translation from this one, the line 2 tail up, right? So you're gonna take the turtle, right, dot up, right, and translation of line 3, right? So we go to xy, right? So dot go to, and it takes two, basically the coordinates, 2 points, sorry, xy values of 1 point, right? Now we need to tail down the step 4, right? And you can see that it's kind of follows for firmly our plan, right? So this is line 1 translation, line 2, line 3, right? Now we are going to translate line 4 from English to code. Okay, so that's one benefit actually, code lines are numbered like this, right? So should our plan too. Okay, so dot um down, right, down, and then basically we're going to move forward by length, and then turn left by 60, and I'm gonna take this one, and I'm going to, and you can see that the rest of the 5 basically steps, rest of all the steps are repeats. So I'm gonna copy paste this, guys. Okay, 5 times. All right, I think that's it. Yeah. Okay, all right, so this is our function. Okay, and we can now call this one. Okay, so what do we call these 3, these 4 values? Parameters. You can also name them sorry, the formal parameters. Okay, and we're going to call this function right here, and then you can see that I have created the turtle named Ted. I'm going to use that turtle. Okay, so that means this should be Ted, right? Okay, and the length, let's say we're going to draw 80. Okay, and I'm going to say x equals 50 and 50. So this is the coordinates. Okay, all right. And this what basically this one is creates a screen, guys, and this is where we basically delete that screen. Okay, and then we can actually write our turtle code, turtle running code in between that 2 lines. Okay, all right, what do we call this?
The assignments for the parameters.
Almost there. Anyone?
What's it start with? The letters it start with?
A?
Assignments?
No.
Parameter assignment?
We call them, so this is the call, right? Call, the inputs in function call is called arguments.
Arguments, yes.
Yeah, we can also call them actual parameters because these are the actual values we pass. Okay, these are just placeholder values in the definition, so we call them formal parameters. These are actual parameters. Okay, the other 2 names are just parameters and arguments. Okay, all right, so you can now run. All right, so it works. Okay, All right, so let's quickly. So later on, I will add the colors and also the pattern, guys. This I wanted to show you. This is the one that I actually did last semester. Okay, see that? That's one pattern that you guys can do. This is the honeycomb pattern. Okay, so either one is fine. You may come up with your own different pattern, which is fine as well. Okay, but I'll post this code later today. Okay. All right. So let's answer this question, and then we can wrap this one up. Okay. Okay. Yep. All right. Name a data type you use in your code.
Strings and integers.
Yes. If you use colors, then there will be like red kind of those things are strings, right? Integers. And it's also a type actually. This is turtle type. That's also a type. Okay. All right. Write an expression you use in your code.
Turtle.
Yeah, this whole function calls are actually expressions. So this one is a expression. This one is an expression. This whole thing is an expression. All of these lines are also expressions. Okay, and then this value itself is an expression, and this just like the value itself is an expression. A variable name is an expression as well. So there are a lot of expressions over here. Okay. All right. So number 3, what's the answer? Imagine you are being asked to draw an equilateral polygon of 100 sides. From the current knowledge and experience you gain so far only from this course, will you be able to easily draw it?
Yes.
Easily draw it? 100?
100?
Yeah.
Yeah. Maybe not. No, because
Well, I mean, it's kind of subjective, but like it depends on your definition of easiness, right? But imagine, so this was 6, right? So for 100, you will have
3.6.
no. So this is for 6 sides hexagon. For 100,
So it would be it would be we did.
so you will repeat.
We did 360 divided by the number.
Yeah,
of
so
sides.
360 by 100. Yeah, so that's the angle. You're right. So that's yeah.
But,
But
like,
now,
the
how many
coordination-
code lines will it have? How many lines of code?
Oh,
So
it would
I
be a
have
lot. It would be a
I
lot.
have 15 over here. I have 12 over here. So for 6 hexagon,
You need one. You need 2 lines per side.
yeah, so 200, right? And I don't think it's easy. Even copy pasting is kind of.
Yeah. Well, you can do it in a loop, right?
There you go. That's the answer. Yeah. So, but we haven't learned it yet, right? So I'm basically making a case for that, right? So that means as of current knowledge from this class, no, you can't do it. We cannot do that yet. So the answer is actually no. My answer would be no.
Okay.
But you, regardless your yes or no, you should be able to explain it. Okay. So the reason is basically one, basically even for copy pasting is painful that many times, and the other thing is, well, will you be able to generalize your function to draw any equilateral polygon, not just 100, not just 6, not 3, right? Any polygon we can, right? Because this code, I mean, if we use this code, this code only can draw a hexagon
Yeah.
because it has. See
You
that?
have to add
Yeah.
delete lines of code per side.
Yeah.
You can't just say, hey, like, look, draw
Yes.
this shape with this length and
Yeah.
this number of sides.
So basically the reason is basically we our code is fixed, and then it cannot actually take a number of side as another input and generate the polygon we want. It
But
can't.
you
Okay.
could do that if you were better at coding.
Yeah, I mean, once we learn the loops, We will, and we will actually do so in week 10. Okay, week 10 we learn loops, and then after that we should be able to just 3 lines of code. We'll be able to do this all of these. Okay, so yeah, so let's learn. We will learn those how to do that. All right. So as of now, we can, and then we are kind of by asking to you guys to repeat like this, I'm making a case for you guys so that you will realize, hey, there's got to be a better method, and we're gonna learn that in the future. Okay. All right. So take a look at when my post my explanation also, guys. Okay. All right. Write a statement other than an assignment statement used in your code.
These are the import terminal if
Yeah. So this is the import statement. I have to is it. Okay. Import statement, and then what's the other one? Oh, I think this is the only one, right? So and later on we'll learn this whole thing as a statement as well, but the more obvious one is the import statement. Okay. All right. Um, two Python result words:
import and if
import, if, and then def, right? Definition, right? So this one also reserved word. This one is a reserved word, import, and down below we have if as well, which we will learn in week 9. Okay. All right. So all right, that's about it. Okay. So let's move on to our lesson, guys. All right. I think not this one. Yeah, right here. Let me open. Good. I'm on this one.
I started on the bus, but it's really it's like taking a bit.
Okay. All right. So we will take this one over here. All right. So we were here, right? So we didn't finish this one. I think we came to this topic right here. We didn't finish section 5.1, right? We learned the return value, right? We did this one, right? And that's actually, you can see it over here. Yeah, this one. See that return? We have to we should we have to return a value to use it as an expression, right? The function call, right? So the good reason right here, like see that this code returns and actually prints um, the correct values, right? And here you can see that I am using my function call as an expression, right? And that expression return 4, and then 4 in turn again gets squared up and then becomes 16, right? So this thing is actually 4, right? See that it's actually return 4, right? So this is 4. So I'm basically essentially I'm actually passing 4 here to same function. So 4 squared again and then gets 16. So in order to do that, we should return our value from function, not print. Okay, print it, just put it in the screen. You only see that value in the screen. There's no tangible thing or value there, right? And that's the idea. So right here, you see the none, right? See that I am printing print 4, right? So I see that value, which is this value, right? And then I pass that and again to print, but I see none because the return value of print is none. So that's the proof. So this is the proof that return value of print is actually none. Okay, so that means if you use print to return a value from function like this one, right, you'll get an error something like this whenever you use it in an expression as an expression right here. And then you can see the explanation. It's a type error because we need we are doing a multiplication over here, and these two things need to be numbers, right? But it's saying that no, hey, you are not giving me numbers, they are none, they don't have values, because this value is actually in here, that value is actually none, right? So I'm trying to multiply none twice, none times none, which is not defined in mathematics, so not in Python. Okay, so it's actually with those kind of errors, usually type errors. So Python expect a number type, but we are not giving number type, we are giving anything else, and it wouldn't work now. So it's a type error. Okay, and this is how you read it. Basically, it's a non-type, and then the operand is star, right, which is a multiplication right here, right? And Python doesn't know what to do because it's not defined in mathematics. Okay, for non-type. All right, and this is the fix by returning the value. Okay, got it? So strive to return from a function always. Okay, and sometimes function or prompt already asks to print it, then it's okay if it's only asked to print it. Otherwise, try to return your value from a function, and then you can see that value by printing it in the main program, printing the function call. And that's what we did over here, print the function call, right, to see the value. Okay, all right, so let's go to the module. All right, so you already learned about parameter, right, and the argument.
Um, so you're saying that when, if,
All
as long
right.
as we define our function with return, then when we can then print the function.
Yeah, to see the value, see the return value. Yes, you will have to, otherwise you will not see it, because it's silently run and the value is in memory now. But to see that value, you have to print it. So you'll have to print the code. Okay. All right. Okay, guys. So this is a good tool. I'm gonna ask you guys to Google this one. I'm gonna go back a little. Okay. Google this one, Python tutor. Okay. Could you all follow me? And then the first search outcome is this one. Click on that, and then click on Start Visualizing. So this should be one tool in your tool set, guys, to debug your code. Okay, and you can see that by default it says Python 3.11, which is good. Okay, and also if you in the future class you may use other languages as well. So basically it's gonna visualize how your code works, right, step by step, line by line. Okay, and then here is basically what Cybook has shown to you. So basically what they have done over here is they have embedded this tool into Cybook because it's a good tool. Okay, that's why. Okay, so they have embedded it over here. So and then you can see that this red line is basically tells you where it's gonna start next line to be executed. Green line going shows you the line just executed. Okay, so you can actually, by clicking next and next, you can go step by step. Okay, so let's follow first one, right? So this is where you start. All right, and then this particular function basically calculate pizza area by the diameter. So it's basically the um, you know circle area calculation, right? You can see that math.py, the pi's value coming from math module, right? And then radius times radius. So it's basically pi to the power r squared, which is the area of a circle, right? And you can see that it's returning a value, right? But this code, basically, we are now running this code. We are right now at this line, this to be executed. Look what happened when you click next, right? See, it doesn't go to the code inside the function, right? No, because it's actually this code belonged to the function. So it basically went to the stayed in the main program and went to the call, the first call, which is this line 7. So now we go back, because now we are executing this function, right? So now we go back and execute code inside the function for that particular input. So you can see that now we went to this line, right? And likewise, we can go next and next. Now it's return the value. Once it return the value, once we click next, this line will get executed and print the result, right? So did you see that? It printed the result, right? So now we go to the next line. So we are about to execute this line. So that means we go back and execute the function code again. Okay. So we go like this, and then we do all this, and then in the end, we basically execute this line, the next line, which is with the results. Okay. Did you guys understand? So this way, you guys can actually use this tool to debug your code, because it's going to end up at the place where your code has a bug and then tells you what it is, and then you can kind of clear, you are kind of clear what to do to resolve the bug. Okay, so use this as another tool set you have in your, you know, tool set to debug your code. Okay, so you can bookmark this website and then use it. Okay, what you have to do is copy paste your code and then test them out. Unfortunately, I don't think turtle code works here. Okay, there's no visualization platform, right? But for, let's say, programming assignment, you can definitely use this tool. Okay, all right, I highly recommend that, because it actually shows you how your code structured, as well as how they connect each part as well, like right here, right? So for example, it also shows you parts of the your program, the global frame, which is the main program, and then the function, right? And then how it actually connect to the call, and then other variable names as well. All right. Any questions? All right, moving on. Whoops. This one. All right. We already did this one, I think, in the rectangle one. Okay. We can actually use call a function we already defined in another definition of a function. And here's an example. In this particular example, so we have a function named calculate circle area function. So it takes diameter and then returns the area of a circle. Right, so this code does that, and you can see that in the next function, right, we are calling this function. See the call. See, here's the call, right? So we are calling this function to calculate the area of that pizza. You know, pizza is a round thing, right? Circular thing, right? So we can call that function to calculate the area of the pizza, right? So, and that's what we have done. So this is basically, see that we are actually defining a function. Inside that function, I'm calling a function that I previously defined. So we call this hierarchical function calls or nested function calls. Okay, we did that in a triangle pattern problem, if you remember. Okay, if you go check my code, I created another function that called the rectangle drawing function, and did that, right? So all right, and then later on today you will see that I will use the the hexagon and then call that function to draw a pattern. I'll define a new function to draw a pattern by calling that hexagon function. Okay. All right. All right. So let's start this one together, guys. Last challenge activity. Okay. All right. So define a function with this name, compute num, that has one parameter and return the parameter minus 5. Okay. So we're gonna define, and all right, and I would recommend writing it here as well, but I'm gonna leave it for you guys. Okay, the doc string, and then so it takes a one parameter, let's say a number, right, and then basically returns, right, parameter minus 5, right? So number minus 5. Okay, and you just need to and you can see that this is my actual parameter value, right? This is my formal parameter, right? And you can see that actual parameter is this one. Okay, so let's run it. Oh, I think I made a mistake. Oh, didn't I return? Oh, still made a silly mistake. Return should be return. I put returns. Okay, I got mixed up with English and Python. All right, let's check. All right. So likewise, you can go. You should go to the next one and then do things. Okay, guys. So and you can see that, right? So in here, right? I'm gonna show you one more difference, interesting thing to recognize. So I have this is my formal parameter, right? Or just a parameter. One is a turtle, right? And you can see that my actual parameter is Ted here, right? And then they are different actually, but they are related, but um, they're completely two different things. But there's a relation, there's a one-to-one connection there, right? And this can be same name as well. I can use a turtle here as well, and doesn't matter, right? So even though this can be same name, it's really important for you to understand that they are different, two different things in here and in here, right? So that's why it can be actually different. Okay, so I'm going to change back the name actually. Okay, so all right, so it can be different names, same name, doesn't matter. They are two different things, but they are related. Okay, so there's a one-to-one correspondence. All right.
Can I look at the number code one more, just a little bit?
Oh, this one. Okay. All right. All right. So here it's a number, but here is actually value read. That's what we are inputting. Okay.
So
Yeah.
the function only has one line of code, which is return a number minus
Yeah.
5. And then value read is outside of that.
Yeah. This is in main program. See, that's in main program.
But it still attributes that input to
Yes.
that. Is that because it's the only parameter?
Yeah. So basically, there's a single parameter, right? So we are actually collecting it here in from keyboard that we are going to. Then we pass it over here. Okay.
For sure. So
Yeah.
if this needed two,
Then you need one more. Yeah. Yeah. Now. Yep. New value for that. Yes. All right, guys. All right, so quickly go this one. We already, um, talk about this one, reasons for defining function. It improve program readability, right? So take a look. So this is my our code, right? So just take a look this, so because this code draws a hexagon, right, take a look at this code, right? But can you tell by just looking at like this, can you tell that it's actually drawing a hexagon? It's hard, right? It's hard because I don't see the name. So if I don't write a function, then my code is like this, and it's really hard to see what I'm doing, right? And that's, see that once I see this name, it's very clear to me what I'm doing, right? So that means, yeah, your code, it's make your code, it's really, easy to read. Okay, so it's improved program readability. Okay, because it tells you what, and basically what we are doing is we we take a particular piece of code that's accomplished a task and give it a name with that task. So now we actually can identify that code with that name. Okay, so that's actually pretty much the definition of a function, right? We actually learned last week. Okay, all right. It's also makes our program modular, right? So like right here, I can use this function in many ways to draw other things, right? So so that become, I can make it more complex patterns out of that. So it's actually but still my code going to be readable and modular, right? So it makes our code modular as well. Okay.
So it's modular in relation to the hexagon. Like when you
Yeah,
can
yes,
debug
you're
things
right.
with
Yes,
the hexagon.
yeah. And then also it also avoid writing redundant code, right? So like for example, um, right, i I don't have to repeat this code again and again to draw another hexagon, right? I can simply call this function, right? So I can do it twice right here by calling it again, right? So and I don't have to repeat that code, right? So right, and then this will create another hexagon, right? So like this one, right? So um, and I didn't have to repeat that set of code again, right? So that's actually the utility of, we avoid rewriting code, redundant code. Okay, all right guys, so it's 12:02. Let's get our break now. Okay, so be here around 12:08. Okay, you're gonna watch the video. Okay,
This I thought he was going to chapter 6. This chapter 5 is harder than chapter 6.
harder harder than chapter 6.
Yeah, chapter 6 is
Okay,
not as hard.
but that's the idea of the immersion. But the thing is, yeah, so we my strategy is expose you guys early and then keep immersing in it, and then you definitely, if you continue, and then by the time 12th week, which is the function part 2, you are basically really good at it. Yeah.
No, and I mean you've gone over it, and I find it really interesting. I had to go over your syllabus again for an assignment in a different class that was
Mm-hmm.
in the introduction to engineering, because it talks about the same things where it talks about in this class and that class
Mm-hmm.
growth mindset, like
Mm.
and the self-directed learning. Like in our book has nothing to do with engineering. It's
Mm-hmm.
just basically saying 20% of the information. You don't come to class to get exposed to the information. You come to class
Mm-hmm.
prepared to scratch the surface a little more, and then 80% of the work has to
Yeah,
happen
yeah, I
outside.
agree.
And it's much more effective to do it with other people.
Yeah.
Like, you know what I mean? Trying to do this yourself, just that's not how it's done.
Yeah, yeah, agree. Anyway, turnout today is low. Probably people are extending the long weekend. Yeah, I get trying to get back, right? Yeah, yeah.
I did. We actually ran into a problem before. I don't know. According to Sean, like
Mm-hmm.
there because well, I defined a function
Mm-hmm.
converting uh, hours,
Okay.
minutes, and
Yeah.
seconds
Mm-hmm.
into just seconds.
Mm-hmm.
So my math is total seconds equals the hours times
Mm-hmm.
60 times 60
Mm-hmm.
plus the minutes times 60 plus
Yeah.
seconds. And then I'm returning total seconds.
Mm-hmm.
And then to define the main, I
Mm-hmm.
have these inputs.
Yeah.
And it's giving, and then I'm printing the conversions, and it's giving me two of them is correct,
Okay. Let's
but
take a look.
but
Yeah.
one of them is wrong. And at first I thought it was I had put the parameters in the wrong order, just like I typed them out wrong, and I was like, but see, for the first one,
Mm-hmm.
for this one the input is one, so that
Mm-hmm.
doesn't matter if it's out
No.
of order.
Yeah. Yeah. Oh, yeah.
But
Mm-hmm.
after solving that problem, it's still giving me 9 out of 11. And
Okay. So let's read the error message.
at this point, that doesn't make any sense because how can you get two right and one wrong when the math is the same?
Um. Well, the thing is, let's see.
I'm not super worried about it. I just popped up essentially.
6 seconds.
What's up, Chris?
Hours, minutes, seconds, and oh, okay. Seconds. This is correct. And this is the template I have given, right? Yeah.
Yeah. Some of
Um.
the most of the code you can't change. I think
Yeah.
it was just the math of multiplying by 60. The
It's
input was
kind
already
of
there.
strange, actually. Yeah. Why it's not giving this one, right? So you are getting a different answer, right? Okay. Seconds.
It is. It's been like this like almost a week, right? I know.
What do you want? What do you want?
Oh, that means this is a logical error. Right? This is a logical error because you are not getting the correct answer. Um,
Okay,
yeah,
I'll take a look.
seconds and hours. Yeah, hours times 60 and 60. Okay.
I did. He said it was canceled. Oh, is it? Yeah, he said.
Oh, here's the.
What you got?
His. Yeah, I think I found it. So see the order, right? So 40 is the number of seconds, and then minutes, then hours. You are taking the other order, right? So this should be see what I'm saying, right? So this should be
Okay.
seconds,
Okay.
minutes,
So it was the same
and
problem
hours. Yeah.
before. Okay.
So this should be seconds, right?
Okay.
Here should be seconds,
Cool.
minutes, and then hours.
All
So
right.
try changing that;
I
it'll work.
definitely
Okay.
will. Thank you
Yeah.
so much.
All right. All right, guys. I just published it, guys. It's in this one. It's in module 5. I think. Let's see. Should have changed the. Let me change the due date. I think it should be today, right? Yeah, that clearly shows we are 1 week behind. Okay. Okay. Um, so this one has useful information for you guys, especially when you need to apply for an internship or a transfer, or grad school. There's a resource for myself as well. Okay, so take a look. It depending on your need as well. So we have seen this already. So one basically usage of function stub is basically, let's say you know what to do and then you're not just ready to write code yet. So basically you can write that function name because you know what to do, and then you can put the pass statement and then do it later. Okay, and then your code still works, and basically what Python does is Python kind of going to bypass that and then goes to the next line. All right, so let's copy this code and then run it and then see how it works. Okay, so I'm going to go here and then, all right. Okay, so and you can see that there's a steps to feed converter program. So this is a unit converter kind of. Okay, and it's running the feeds, right? And here the calorie calculation is not ready yet, so we have pass. So this is the pass here is a statement. Okay, so it's the other another statement type that we just learned today. Okay, so we already learned assignment statement, right? What are the other statements types we learned? Assignment statement is the first. Then anyone the other statement type we just discussed also as part of that group problem. Other types of statements. Okay, first one we learn is assignment statement. Then no, not yet. The import statement, right? So we import statement we learn, and there's another one we learned this week and then also last Tuesday, right? Last Thursday, the return statement. So three statements so far: assignment statement, import statement, return statement. This is the fourth one, the pass statement. It's also a type of statement in Python. Okay, so basically allows us to basically ignore that line code and then go move on to the next one. So if we run this one, see what happened, right? All right, so let's say like 50 steps. So you can see that it did this calculation, right? And then in here we are calling this function, right? See right here, that part is none because it's not complete yet, right? But the code ran, right? So if you want to check your code and then but you are just not ready yet to write exact code, you can actually use a pass statement inside a function. Okay, all right. Yes.
When I tried to run it, it gave me a force error on line 12. Bad input on line
um,
12.
could you check thanks. All right.
So it printed because we're skipping the steps to calorie function.
Yeah, but if yeah, so see what happened if we remove this line, right? So now basically it's a error, indentation error, right? So remove, because all function except at least one line of code inside with indented, right? So that means if we are not yet ready to define this function completely, we can put pass,
And then
right?
at the bottom, you're
Right.
you're assigning calories to run that
Yeah,
function.
so we are basically trying to run it, but it's not complete, right?
But it's cool because you're printing the string calories
Yeah,
with the well, I guess yeah, that's the assignment for the function.
yeah, so it's, yeah,
It's just coming out.
yeah, it's none, right? So
It's out.
but if I don't have it and then code doesn't work, I cannot move on to the next line, right? So this is a nice way to write, kind of bypass. You know what to do, but you are not just ready yet, but you can check the rest of the code. Okay, all right. And there's another way of doing that, which is through non-implemented error. So that allows you to raise an error saying that you yet to implement that. All right. So make a new box, and you can see that it's a non-implemented error. Okay. So it returns that. Okay. So there's this, like a similar purpose in there. So either we can, so we call them. This is a function stub, and the one above, and this one also function stub. Okay. All right. So we call them function stubs. Yeah.
So
Okay.
we're using the command raise.
Yeah. So that's, you can either do pass. Pass is the easiest, or you can do this way as well. Okay. So there's a tiny difference to this one. They are both. Yeah. Yeah. All right. So we already talked about this topic, printing from a function, right? And then remember, we also discourage that, right? So always, if your function must return a value, strive to return it rather than printing it. Okay. But sometimes, function actually doesn't return anything, so it's actually print. So that kind of function is called actually a void function. So void means nothing, right? Void means nothing, right? So basically, there's no return value, so it's actually none, like print itself, right? So print itself, in fact, a void function. Okay. The another name for this kind of function is actually non-fruitful function. So fruitful means something tangible, right? There, right? So non-fruitful mean nothing, no value return. So we also call them non-fruitful function. Okay. Same for void function. And the other opposite is basically the fruitful function, which is a function that returns a value. Okay. So we call it a fruitful function. Those are kind of synonyms. All right, and then this one, if you play this one, you will see that there's if you print multiple times, you'll get none as well. All right, so we already saw that. So let's do this one together, guys. All right, the last challenge activity. All right, two name salary pairs are read from input and are passed as argument to print earnings function. Okay. Define a function print earnings that has two parameters and outputs the following all in one line. Okay, so these are okay, and you can see that this, they are saying that okay, so we have to print, not return. Okay, so that's why the name just print earnings, right? So we have to print. All right, So let's write our function. So name salary payers, it's gonna actually read. Okay, so def, and looks like this is our function name. So we're gonna take this name, and salary, so name and salary, it's gonna read, right? So we're gonna write name and salary. All right, and I'm gonna let you guys write the doc string. Okay, all right, and then basically it's gonna print, right? Okay. This order, right? The value of the first parameter, which is name. So we're gonna print name, and then earns, right? Earns, and then the value of the second parameter, which is salary, and then dollars per year. All right, that's it. So you can now run it. Oh, I made a mistake. Okay, so I think there's an extra space. We need to remove that. Okay. All right. So let's see where are those. Yeah, earns. See, right. Yeah, right before earns, right before this value. All right. So we need to remove these two spaces and this one too. Check again. All right, there you go. Okay. All right. All right. So I'm gonna stop right here, guys, and we will finish this module on Tuesday. Okay. So when we go over on the few things during this module, okay. So the graded discussion, this one. So you are given a bunch of built-in functions in Python. Okay. So these are the ones, right? And then you pick two, right? And then you demonstrate it to the class how they work. Okay. All right. So and I have given I think see a template code right here as well, so you can use this code. Okay. So this another tool that you can run Python. Okay. So you can use this template code, and basically you'll have to embed it into Canvas, right? And then and those instructions are here. And then once you write your demonstration, right? Like some of you guys have already submitted, right? And then make sure to reply to a friend, okay, in the class. Okay. So and these are the functions that you have to pick. Okay. All right. So that's the discussion. And the next one is the Scilab. All right. So basically, you collect seconds, minutes, and hours in that order, guys. I think I'm telling you them now. Yeah. So basically, this should be this is seconds, this is minutes, and this is hours, guys. Okay. So you have to make sure that you collect in that order, and then these are the inputs, and then I have given you guys still loading a template. Okay, still loading. Come on. Okay, there's something wrong. Okay, that's fine. Let's see. All right. So yeah, okay. It's actually didn't load. Let me restart, refresh. It's connected. Okay, hopefully. Okay, now the cursor, even the cursor doesn't work. So basically, what you have to do is, you are writing a function to convert everything to seconds, and then this is the way they have written the output. So you have to actually uh, output that way. Okay. So come on, it's probably stuck now. Okay. All right. So let me close some of these. Anyway, I have given you guys a template, so try to use that template. Okay, so it's in Cybook. Okay. All right, I'm going to close this and this. All right, so let me move on to the next one. Okay, so yeah. All right, so the next one is actually the assignment, the programming assignment. Okay, so It's really slow. All right. This is the one. Convert units. All right, guys. So this one basically, what you have to do is write a general program that takes a quantity in 1 units, which is the starter units, and amount, and then you have to convert it to the other units, the amount in other units. So you have to return that value. Okay. So take a look at the rubrics. This is what the prompt is. Okay. And let me go to the code check and I'll show you guys what to do. Okay. All right. You have to write your name and LMS ID. Okay. So you know how to do it. Okay. And right here, I have given you places for both understand and match steps. They are not mandatory. So I highly recommend writing them. Let's say you do some workout for understand, you can type it over here. Okay. But this one is mandatory, the plan. So if you miss the plan but your code still work, but the TAs will basically go and deduct 2 points. Okay. So make sure to write your plan, and then this is where you write your function code. Okay. And then you have to follow this example exactly, right? Like this one, the way I have used round and then call the function, right? So you have to follow this example and then do it, run it for the rest of the two cases, test cases. Okay. Over here and here. Okay. There are two places, and make sure to call your main function over here. Okay. So basically like this, a main, right? That's it. Okay. All right, that's it. So that's how you submit it. Okay. All right, so that's about it. So let's go to the problem today, guys. Okay. So which is the flower one. Okay. So we can actually draw a flower. So I just published it. Okay. All right. I just published it, guys. It's in module 5. Okay. Flower. So here's what I I think I close it. Okay, I'm gonna get it back. So basically, you're gonna first write write a function to draw a circle. Okay, so that's the first part. Then you're gonna basically use it to draw a pattern of flower. Okay, and then here is what I imagined. I think I probably have it in the history. Um, Maybe I can go it from here. Okay, so I'm going to show you what I expect from the flower, the simplest one. Okay, yeah, this one. Okay, so I'm going to run this code. This is the one that I previously wrote. Okay, we'll run this code, and you'll see that I've used circles as petals, right? And this is the flower. Okay, and we have been doing similar things with rectangle already, right? So then this is actually the simplest flower that we can draw using circles. Okay, so this is kind of thing that what I expect. Okay, all right, it's in module 5. Okay, so is it this one? No, not this one. This one. Okay, flower. Okay, so let's pair up, guys, and then read it, and then first get the petal done, right? So the circle done, and then you can later extend it to the pattern of flower. Okay.